Welcome to the Kia dealer in the Neubrandenburg region of Germany. Kia is one of the most successful and innovative brands in the Netherlands. It is not without reason that they can be found as standard in the top 3 best-selling cars and that they are the only brand that dares to give a warranty of up to 10 years. See, we like that. Vaneman is therefore a proud dealer of Kia. And you notice that. Our team lives, eats, and breathes Kia. We are not only enthusiastic enthusiasts, but also well-trained specialists. We know all about it. Does this sound like a challenge? Well done, because the first customer to ask us a question about Kia that we can't answer. Diagnosis and repair plan Kia Rio 3.1.2 CVVT ComfortLine G 4LA petrol engine, year of manufacture 2014. Known problem with this car and engine: stuttering when starting off at low revs. The car doesn't go above about 15 kilometers per hour. When standing still, no further throttle above about 5,000 RPM, and the engine will choke. Complaint has been intermittent but now persistent. No error codes in engine control unit. Parts already replaced. Timing chain set complete. Spark plugs. Ignition coils. Camshaft sensor original. Fuel system, equipped with Euro 98 with octane booster. Already checked and approved. Catalyst and center silencer are not tight. Fuel pressure is okay. Spark plug wiring visually and electrically correct. Compression approximately 11 bar on all cylinders. Read with AUTL MS909, no error codes. Likely directions: no error codes plus clear speed limitation and power loss are often indicated with this engine. Air mass measurement or intake system error, air mass meter or large false air. Throttle body adaptation or position deviation, mechanical or electronic. Camshaft or crankshaft signal synchronization chain is new, but possibly one-tooth timing error or reference value is incorrect. Valve clearance, hydraulic or mechanical, this type is sensitive to valve clearance that is too tight. Variable valve timing, CVVT adjuster or oil pressure problem. Exhaust back pressure still too high under load. Catalyst internally loose or partially closed. Control device software outdated. Update required. General diagnostic steps. Step 1, basic engine check. Bring the engine up to operating temperature. Fuel trim and view live data at idle about 2,000 RPM and about 4,000 RPM. Check short-term fuel correction. Long-term fuel correction. Air mass meter value in kilograms per hour. Intake pressure on this engine should not show any strange fluctuations. Throttle position and accelerator pedal position, or both, are linear and logical. Camshaft position in degrees relative to crankshaft. If trims are strongly positive or negative, suspect air mass meter or false air. Step 2, false air and intake system. Carry out a pressure test or smoke test in the inlet path. Check intake manifold, PCV valve and hoses, brake booster line, connections around throttle body. If there is false air, the engine often reacts poorly at low speeds and under load. If necessary, temporarily disconnect the air mass meter. In many engines, the engine then switches to emergency values and sometimes runs better if the air mass meter is incorrect. Step 3, check throttle body. Dismantle and clean the throttle body to remove carbon deposits around the valve edge. Check for play in shaft and gears. Carry out throttle adjustment using the Kia diagnostic device and follow the Kia procedure. Check in live data. Minimum and maximum throttle position. Accelerator pedal sensor, both lanes whether they run at the same time. In case of deviating values or malfunctions, replace the throttle body. Step 4, camshaft and crankshaft synchronization. View camshaft and crankshaft signal simultaneously with scope. Find reference waveform for this G4L, a motor, and compare. Physically check timing marks. Set the crankshaft to top dead center of cylinder 1 and check the positions of both camshafts. One tooth error can cause significant power complaints without an immediate error code. Also check the CVVT adjuster for blocking. Check oil quality and oil pressure. Adjuster only works properly with correct pressure and clean oil. Step 5. Variable valve timing and oil. Check oil level and viscosity and use correct specification. Check the oil filter for internal contamination or collapse. Remove control valves from CVVT valves and check for dirt and sieves. Clean ultrasonic if necessary. Test the control of CVVT with a diagnostic device if possible. If position measurements differ, suspect the adjuster or control. Step 6. Valve clearance check. G4LA engine is sensitive to valve clearances that are too tight, especially on exhaust valves. Remove valve cover. Measure all valve clearances, cold according to factory specifications. With zero clearance or too little clearance, cylinder combustion and power are poor, especially during hot operation. If necessary, adjust shims or have valves adjusted. Compression can still be acceptable, but cause complaints under load. Step 7. Exhaust and catalytic converter under load. Despite an earlier check, still perform a pressure test in the exhaust. Screw pressure sensor into lambda port or in front of catalytic converter and measure pressure at different speeds. Too high pressure indicates partially sealed catalyst or internally loosened core. If in doubt, temporarily place a test pipe and make a test drive only on closed grounds. Step 8. Ignition and injection under load. Use the scope to check the secondary ignition image of all cylinders under load. Wear of ignition coils or spark flashover can occur while driving without an error code. Test injector balance by cylinder deactivation or by measuring fuel corrections and speed drops per cylinder. Monitor fuel pressure under load with a manometer plus possibly a pressure sensor in live data. The pressure must not drop. Step 9. Software and adaptations. Check whether there are TSBS and software updates for this engine and complaint image. If update available, reprogram motor control unit. Reset all adaptation values and follow the running-in procedure. Specific checkpoints without error codes. Air mass meter and inlet temperature sensor often not a direct error, but an incorrect value. Throttle reference and idle control adaptations. CVVT reference values at idle and at higher speed. Sensor power and mass measurement poor contact in mass can cause strange complaints. Repair plan in order of logic and costs. First phase checks and simple work. Perform a visual inspection of the entire inlet and vacuum hoses. Smoke test for false air. Remove throttle body. Clean and relearn. Replace oil and filter, if not recently with correct specification. CVVT remove and clean control valves. Cost estimate. Labor about 2 to 3 hours. Material costs oil plus filter and cleaning material, a few tens of euros. Second phase, targeted diagnosis with measuring equipment. Scope measurement camshaft and crankshaft signal. Scope measurement ignition under load. Fuel pressure test under load. Exhaust pressure measurement for catalytic converter. Labor about 3 to 4 hours. Perform targeted measurements during a test drive. Third phase mechanical corrections. If timing is not exactly correct, reset distribution timing. If valve clearance is out of specification, correct clearance. Labor distribution, check and correction 1 to 2 hours, depending on setup. Valve clearance can be adjusted for several hours, depending on the shim system. Fourth stage component replacement, if necessary. Replace air mass meter, if values are demonstrably incorrect. Replace throttle body, if settings or running are still incorrect after cleaning and adjustment. Replace CVVT, adjuster if position remains unstable or not within specification. Replace catalyst if back pressure is proven to be too high. Only replace ignition coils if the scope image is poor despite a previous new set due to the quality of replacement parts. Cost indication for parts and words. Original air mass meter averaged between 150 and €300 excluding tax. Original throttle body averages between 200 and €400 excluding tax. CVVT adjuster averages between 200 and €450 excluding tax. New catalyst averages between 400 and €800 excluding tax, depending on quality. Valve clearance of set shims or parts averages a few tens to more than €100 excluding tax. Average hourly weigh. Universal garage averages between 75 and €125 per hour excluding tax. Dealership often between 100 and €150 per hour excluding tax. Maintenance and intervals specific to this engine. Minor service every 15,000 kilometers or 1 year. Major service every 30,000 kilometers or 2 years. Always use oil according to Kia specifications and do not exceed the interval. Spark plugs usually every 30,000 to 60,000 kilometers, depending on type. Air filter check every service and replacement on average every 30,000 kilometers. Lifespan of important parts indicative. Ignition coils often last more than 100,000 kilometers, provided good quality. Air mass meter often more than 150,000 kilometers. Throttle body varies, but contamination is often the cause of complaints. Catalytic converter normally more than 150,000 to 200,000 kilometers with proper maintenance. Prevention of future problems. Always replace oil and filter on time. Only fill up with good quality fuel. No prolonged driving at low speeds and high engine load levels. Allow the engine to warm up to temperature regularly and do not do short journeys. Preventively clean the inlet and throttle valve every few years for heavy city use. Summary advice for this car. First, accurately view live data, fuel trim, air mass, throttle valve, and camshaft position. Check the intake for false air and clean and teach the throttle body. Check oil quality and clean CVVT control valves. Second, check camshaft and crankshaft synchronization with scope, plus check mechanical timing. Measure valve clearance. Third, test exhaust pressure under load plus assess ignition and injection pattern under load. Only then replace expensive components such as air mass meter, CVVT adjuster, or catalytic converter. If you want, I can write out a concrete measurement plan per step with guideline values for the live data so that you know exactly what to pay attention to during the test drive. Brand Kia. Model Rio. Type 1.2 CVVT ComfortLine. License plate not stated. Chassis number not stated. Subject engine. Engine code G4LA, capacity 1,248 cubic centimeters, 4 cylinders. First registration 2014. Fuel gasoline. Below is a practical overview for a garage mechanic specifically aimed at this type of Kia Rio with G4LA engine. Known issues. Fuel gasoline. Transmission usually manual, sometimes automatic. Front-wheel drive. Year of construction, relevant production period approximately 2012 to 2015. Common problems. Contamination in the throttle valve and inlet causing unstable idling and stalling. Ignition problems due to defective ignition coils and spark plugs. Oil consumption due to neglected oil changes. Valve adjustment problems at high mileage due to mechanical valve tappets. Wear and tear of engine mounts, vibrations when shifting and idling. Wear of clutch plate, pressure group and release bearing on manual gearbox. EGR and intake contamination, especially during many short journeys. Known malfunctions and recalls. Sporadic software updates, engine ECU and ABS. Always check online via RDW and manufacturer for campaigns per chassis number. Vulnerable parts. Ignition coils and spark plugs. Clutch kit for manual gearbox. Stab-eye rods, control arms and ball joints. Brake discs and pads front axle. Battery and alternator for city use. Problematic engines. The G4LA is basically reliable with proper maintenance. Problems mainly arise from long oil intervals and poor oil levels. Recommended construction years and versions. From 2013 onwards, most teething problems have disappeared. Avoid vehicles without a demonstrable maintenance history or with extremely short city journeys. Diagnosis general. Diagnostic steps. Visually check under the hood and under the car for leaks and damage. Read engine, ECU, ABS airbag, and BCM for error codes. Perform a test drive on a cold and warm engine, including highway and traffic jam simulation. Live data check fuel trims, lambda values coolant temperature ignition failure. Mechanical control of engine and drivetrain. Basic electrical check battery, charging voltage ground points. Common malfunctions. Rough running and holding with dirty throttle valve and worn spark plugs. Engine failure lamp through P0300 through P0304 misfire. P0110, one air mass meter and intake related. P0400 EGR system. Diagnostic equipment. Universal OBD2 diagnostic tester with preferred brand-specific functions. Digital multimeter. Oscilloscope if available for ignition coil and injector tests. Compression gauge. Leak test device for cylinder leakage. Smoke machine for detecting false air. Hand tools, torque wrenches, Torx and Allen. Electrical faults. Start with battery check voltage, at rest at least 12.5 volts. Check charging voltage between 14 and 14.5 volts with the engine running. Check ground connections visually and with voltage drop measurement. In case of strange electronic complaints, always visually test fuses and relays. Read and interpret error codes. Scan all control units. Record error codes including freeze frame. First check basic issues, power supply, ground plugs and mechanical causes. Clear error codes and then perform a test drive. Correctly diagnose recurring codes according to the workshop manual. Engine diagnosis. Check mechanical wear. Listening to rattling, tapping and metal sounds, cold and warm engine. Check oil level and oil condition. Check for leaks at the valve cover of the crankcase crankshaft, seals in the water pump. Check the timing chain for rattling during cold starts and abnormal camshaft, timing with a diagnostic device, if possible. Measure compression. Engine at operating temperature. Remove all spark plugs. Open the throttle completely. Start each cylinder by turning it several times. Compare compression values per cylinder with a maximum deviation of 10%. Turbo and injectors. This engine does not have a turbo. Check injectors with resistance measurement. Listening with stethoscope. Possibly test with shutting off injector per cylinder via diagnostic device and looking at speed response. Cooling system inspection. Check coolant level and color. Switch on the fan control at around 90 degrees. Control thermostat for running too cold or too hot with live data. Check for leaks in radiator, heater hoses and water pump. Recognizing early engine damage. Metallic tapping bearing problems. Black burnt spark plugs with lean or rich mixture. Mayonnaise under oil cap head gasket indication. Overpressure in cooling system and coolant loss. Diagnosis drive and gearbox. Gearbox problems. Difficult shifting, cracking in second and third gear. Oil leakage from drive shafts or gearboxes. Howling and yawing at certain speeds causes wear and tear. Manual gearbox. Check link. Skidding when accelerating in high gear. Point of application very high. Noises when pressing and releasing the release bearing. Change oil around 150,000 kilometers or sooner under heavy loads. Automatic gearbox if equipped. Control oil color and odor. Jerky shifting at low speed. Periodic oil change around 90,000 kilometers if manufacturer allows. Drive shafts and CV joints. Check for cracks in rubber covers. Play when turning the shaft. Ticking sound when fully turning in and pulling away CV joint. Chassis and brakes diagnosis. Check shock absorbers. Visually check for leaks. Push test and test, drive for reverberation and restlessness. Average lifespan around 100 to 150,000 kilometers. Brake components. Brake pad thickness front and rear. Edge formation and rust on brake discs. Handbrake effectiveness and equality left-right. Known issues. Stuck brake calipers due to guide pins and pistons. Vibration when braking due to warped or uneven discs. Steering system. Check play in steering box and ball joints. Check steering balls and tie rods. Check alignment for skew and uneven tire wear. Electronics diagnostics. Electronic malfunctions common. Airbag lamp due to broken cable under seats. Central locking and remote control by key or receiver. Radio and speakers due to broken cable in door passage. Battery and alternator control. Battery lifespan averages 5 to 7 years. Charging voltage and battery test with battery tester. Check alternator diodes if noise or leakage current is suspected. Instrument panel and comfort electronics. Check for loose ground points behind the dash. Check fuse box and engine compartment and interior. Repair and repair plan. Draw up a repair plan. First, write down all customer complaints exactly. Record error codes and findings after diagnosis. Create a list of necessary and recommended repairs. Prepare quotation with labor components and additional costs. Plan work sequence after approval. Prioritize inspection and replacement. Safety braking steering tires immediately. Engine oil and coolant. Electrical faults that lead to breakdowns. Comfort complaints last. Urgent replacements. Brake pads and discs with minimal thickness or cracks. Battery with starting problems and poor test value. Worn distribution components and serious oil leaks. Original versus imitation parts. Original parts, higher price, but better fit and durability. Aftermarket, a brand, often good price quality. For safety parts, brakes and suspension, preference is given to a brand or original. Parts and labor costs. Average part prices, excluding VAT indication. Brake pads for about 50 to 70 euros. Front brake discs cost approximately 100 to 150 euros per set. Shock absorbers each about 60 to 150 euros. Battery about 100 to 150 euros. Clutch set approximately 250 to 400 euros. Ignition coil each about 40 to 60 euros. Spark plugs set about 30 to 50 euros. Hourly wage. Universal garage, about 50 to 70 euros per hour. Brand dealer, about 80 to 100 euros per hour. Maintenance costs. Small service, including oil and filter, averages 150 to 200 euros. Major service, including spark plugs, air filter, cabin filter and brake fluid. Approximately 300 to 450 euros. Maintenance and intervals. Minor service, every 15,000 kilometers or 1 year. Major service, every 30,000 kilometers or 2 years. Spark plugs every 60,000 kilometers or 4 years, depending on type. Brake fluid every 2 years. Check coolant around 5 years and replace if necessary. Gearbox oil, manual gearbox around 150,000 kilometers. Part inspection frequency. Brakes, lights, suspension, steering parts at every turn. Air conditioning and interior filter every 2 years. Test the battery annually on vehicles older than 5 years. Annual maintenance costs average. With normal use, approximately 400 to 600 euros per year, including minor repairs. Part life average. Starter motor about 150 to 250,000 kilometers. Dynamo about 150 to 200,000 kilometers. Battery 5 to 7 years. Clutch in normal, use 150,000 kilometers or more. Shock absorbers 100 to 150,000 kilometers. Recognition of replacement need. Difficult starting and low battery voltage. Clutch slippage and noise. Knocking and leaking shock absorbers. Vibration and long braking distance. Prevention of future problems. Maintenance measures. Always correct oil specification and replaced on time. Regularly drive long distances to limit condensation and pollution. Replace filters in time. Driving style. Drive calmly and warmly. Do not immediately rev to high speeds. Avoid prolonged full throttle and unnecessarily high revs. Do not hang on the clutch at traffic lights. Liquids and oils. Often use manufacturer-prescribed viscosity, 5W30 or 0W20, depending on specification. Do not mix coolant of correct specification with universal agents, without checking. Purchase used car. Points of attention. Check cold start behavior. Take a test drive and pay attention to noises from the engine box and chassis. Check the underside for rust and leaks. Questions for seller. Maintenance booklet and invoices. Last replacement oil spark plugs, brakes, clutch. Whether engine or gearbox repairs have ever been carried out. Maintenance history. Preferred car with demonstrable maintenance at intervals. Check at RDW for mileage and damage history. New or used parts. Recommend new parts. Brake suspension, steering parts, engine internal parts. Used parts can be added. Body parts, interior parts, electronics such as control panels. Average price difference. Used parts are often 50 to 70% cheaper. Pay attention to warranty and origin. Engine overhaul or replacement. Benefits of overhaul. Retain original engine number. Targeted replacement of worn parts. Disadvantage, higher working hours and downtime. Advantages of a replacement engine. Faster turnaround time, often lower total costs in case of heavy damage. Risk of unknown condition of used engine. Average costs. Complete overhaul of a small petrol engine, approximately 2,000 to 3,500 euros. Used engine, including installation, approximately 2,000 to 3,000 euros, depending on availability. Gearbox repair or replacement. When to overhaul. Bearings and synchronization rings with wear, but otherwise good housing. For specific acceleration problems. Replacement costs. Used manual transmission, including installation, approximately 1,000 to 1,500 euros. Manual transmission, overhaul approximately up to 2,000 euros, depending on damage. Choice of petrol or maintenance and reliability. For this type of car and motorcycle, gasoline makes the most sense. Diesel is only interesting for very high annual mileage, more than 25,000 kilometers per year. Costs and risks of diesel. More expensive fuel systems. Particulate filter and EGR problems. Higher road tax. Summary advice. Recommended year of manufacture and engine. Kia Rio with G4LA petrol engine, around 2013 to 2015, with demonstrable maintenance. Avoid cars with no history or with neglected oil intervals. Maintenance plan for problem prevention. Change oil and filter annually or every 15,000 kilometers. Brake fluid and full brake check every 2 years. Replace spark plugs in time and clean the throttle valve. Regularly check suspension and alignment. Annual cost forecast. With average use, approximately 400 to 600 euros per year in maintenance at a universal garage without major additional repairs. This overview can immediately serve as a basis for diagnosis and repair plan for this Kia Rio with G4LA petrol engine. Kia 2. Car, Kia Rio 1.2 CVVT ComfortLine engine code G4LA, petrol, 2014. Complaint: engine stutters and does not rev properly. You do not want a repair plan, but an explanation, causes, and how to prevent this in the future. Language note: you don't want putting things before and in sentences not to be used, but and. I understand this as, I like clear, simple sentences without unnecessary words. 1. Possible causes of stuttering: not getting up to speed. Without a real diagnosis plan, but still in plain language. Ignition spark plugs. Worn spark plugs. Bad spark plug wires or ignition coil. Result: irregular combustion, stuttering during acceleration. Fuel supply. Dirty injectors. Dirty fuel filter. Result: too little or irregular fuel, especially noticeable when accelerating or at higher loads. Air intake. Dirty air mass meter or sensors. False air, crack in hose, leakage. Result: air and fuel ratio becomes unbalanced, engine responds slowly and jerkily. EGR and intake dirty, if applicable. Carbon deposits in intake tract or valves. The result: less good airflow, restless running, and less power. Ignition and engine sensors. Defective lambda sensor, crankshaft sensor, camshaft sensor. The engine computer controls the engine less well, may stutter or go into limp mode. Clutch and transmission, indirect. Slipping clutch. The engine can rev just fine, but the car barely pulls, sometimes also feels like not moving forward. 2. How do you prevent this in the future? Without going into details of repair. A. Have maintenance done on time. Replace spark plugs according to factory schedule. Replace air filter and fuel filter in time. Change engine oil plus oil filter on time. Clean oil and filters, ensure that the engine and sensors continue to work better. B. Fuel and driving style. Refuel at reliable stations, large company. Less chance of contamination and moisture in the fuel. Do not drive only short distances all the time. Occasionally a longer ride. So that the engine warms up and pollutes less quickly. Do not always run the engine at extremely low speeds. Occasionally pulling slightly, within the normal limit, keeps the intake and exhaust cleaner. C. Don't ignore signals. Take the check engine light more seriously. If you start to experience problems, do not continue driving for months. The sooner the cause is addressed, the smaller the consequential damage. D. Have periodic preventive checks. An overall readout, OBD. A visual check of plugs, hoses, and air inlet. This is not a repair plan, but it is a way to spot emerging problems earlier. 3. Summary in very short, clear sentences. Stuttering is usually caused by ignition, fuel, air, or sensors. Worn spark plugs, dirty injectors, or air leakage are very often the cause. Prevention is mainly done with timely maintenance, good fuel, and not driving for too long with complaints. Extra, occasionally take a longer ride, let the engine warm up thoroughly, and do not ignore signals, lights, or faltering. Can you please tell me some information that is unfortunately not mentioned? In which gear and at what speed does it stutter the most? Whether there are any lights on the dashboard. Then I can estimate the causes more specifically.